Today we will discuss about phase plane trajectory problem. So before going to these lectures, you have to read through the materials I have shared in your Google Classroom. What is a phase plane? What is phase trajectory? What is singular point? What are the types of singular points? How can you construct phase trajectory using methods of isoclanes and method of delta? So here the problem is a linear second order servo system is described by the equation E double dot plus 2 theta omega n E dot plus omega n square E equal to 0, where theta is 0.15 and omega n is 1 rad per second. E of 0 is given as 1.5 and E dash of 0 is given as 0. Determine the singular point, find the type of singular point, construct the phase trajectory using the method of isoclanes. This is our question. So first we will find the singular point of this system. For finding the singular point, you have to write the state equations of the system. So I am taking x1 and x2 are the state variables. Let x1 is equal to E and x1 dot is equal to x2, that is equal to E dot. That is your first state equation. Now x2 dot is equal to, what will be x2 dot? X2 dot is equal to E double dot. Now apply x1 dot and x2 dot and x1 x2 in the given equation of the question. So our equation will be changed like this: x2 dot plus 2 theta omega n x2 plus omega n square x1 is equal to 0. Now apply the values of theta and omega n. Now our state equation, second state equation will become x2 dot is equal to minus x1 minus 0.3 x2. So 1 and 3 are your state equations. This PDF file also I will share to your Google Classroom. So for finding the singular points, first we have to substitute the two state variables, the derivatives of two state variables. Take the derivatives of two state variables and equate it to 0. So substitute for x1 dot is equal to 0. When you substitute for x1 dot equal to 0, what will happen? x2 will be 0. Now substitute for x2 dot equal to 0. When you substitute x2 dot equal to 0, this x2 is already 0. Now x2 dot is also equal to 0. Then x1 will be 0. So for finding the singular point or equilibrium point, singular point is also called as equilibrium point, you have to substitute the derivatives of state variables into 0. Then if you substitute these derivatives of state variables into 0 in this equation, you will get x2 equal to 0 and gradually x1 will be also equal to 0. Hence our singular point is at the origin, that is singular point is at 0, 0. That is the first question, answer to the first question. The next question is we have to construct the phase trajectory by using the method of isoclanes. So now we will discuss that. For constructing the phase trajectory, first we have to find the slope S. Slope S is equal to dx2 by dt divided by dx1 by dt. That is actually what is dx2 by dt? dx2 by dt is x2 dot and dx1 by dt is x1 dot. So the equation is x2 dot by x1 dot is equal to. So we can write x2 dot by x1 dot is equal to. Substitute the equations. Then your equation will become like this. And we get S is equal to minus x1 by x2 minus 0.3. Now from this equation we can get an equation for x2 in terms of S and x1. So equation for x2 is minus x1 divided by S plus 0.3. The next step is we have to substitute different values for S, and that is the first step. We have to substitute different values for S. So I am selecting, for this problem I am selecting minus 2, minus 1, minus 0.5, 0, 0.5, 1 and 2 are 4 as the different values of S. So these values, we have to select these values for S. Okay, we have to choose different values for S. And the next step is we have to find angle alpha. Angle alpha is actually tan inverse of S. So we will get the angle like this: minus 63, minus 45, minus 27, 0, 27, 45, 63, etc. Now, in the below table, in each slope, for each values of slope, we have to find 2 points. That means we have to give values for x1 and find the values for x2. So I am giving different values for x1. First, in the first slope, that is at s is equal to minus 2, I am giving for x1, I am taking 1 and 2 as the values. Then if I am substitute x1 in this equation as 1, substituting in this equation x1 is equal to 1 and s is equal to minus 2, I will get the value of x2 as 0.6. Again, take x1 as 2 and substitute here x1 as 2 and s is minus 2. I will get x2 is equal to 1.2. Repeat this step for different values of s. That is, I have to take different values of x1, x2. When s is equal to minus 1, then s is equal to minus 0.5, etc. Why I am taking is, these are different isoplanes. At these slopes, I am plotting isoplanes. At the slope minus 2, minus 1, minus 0.5, all these points I have to plot isoplanes. And the isoplanes, I can plot isoplanes through the points like 1, 0.6 and 2, 1.2. So, by taking this, I will show you the graph. So here in this graph you can see I am plotting different isoplanes like this: s is equal to minus 2, s is equal to minus 1, s is equal to 0, s is equal to 0.5, s is equal to 1, s is equal to 2, etc. So how I am plotting this? For s is equal to minus 2, I have taken the points as x1 is equal to 1 and x2 is equal to 0.6. That we can see here, this is 1 unit. So here for s is equal to minus 2, I am taking the values for plotting this slope or this isoplane at s is equal to minus 2 as, for x1, I already in the table we find out the values for x1 and x2. When taking x1 is equal to 1, we got x2 is equal to 0.6. So that is the first point. When x1 is equal to 0.1, x2 is 0.6, that is approximately here. Now, when x1 is equal to 2, x2 is 1.2, that is approximately here. So by joining these 2 points, draw a straight line. That is the isoplane for slope s is equal to minus 2. So here we already got the singular point at 0, 0. Since the singular point is at 0, 0, all the isoplanes will pass through that singular point. In the phase trajectory, the method of isoplanes, all isoplanes will pass through the singular point. So we already got 2 points, and connecting these 2 points, draw a straight line. That will be s is equal to, that will be the isoplane at s is equal to minus 2. Similarly, draw isoplane at s is equal to minus 1. So for s is equal to minus 1, I am taking values for x1 as 1. when I take x1 is equal to 1 and s slope is equal to minus 1, I got x2 is equal to minus 1.4, that is approximately here. And when I am taking x2 is equal to, so x2 is equal to 2, x1 is equal to 2, I am getting x2 is equal to 2.9, that will be approximately here. So by taking these 2 points, or by taking the one point, that is x1 1 and x2 1.4, and taking the origin as next point, you can draw the isoplane, because since equilibrium point or singular point is at the origin, all isoplanes will pass through that origin. So similarly, you have to draw all isoplanes and mark here the angle alpha. So here I am marking angle alpha is equal to minus 63, that is at s is equal to minus 2, tan inverse of s is minus 63, and s is equal to minus 1, alpha is minus 45, etc. So while drawing the isoplanes, you have to remember one thing, that is when you draw these isoplanes, there must be some minimal distance and not more distance, because we are drawing the phase trajectories depending upon the isoplanes. So if the isoplanes are too close, it will be difficult for you to draw, and if isoplanes are too distant, the phase trajectory, the phase trajectory plot will not be accurate. So since we are doing it by hand, you have to select it in such a way that there should be some minimal distance but not more distance. So if you select points like this and draw one or two isoplanes, you will get an idea about that. So that is the next step, drawing all the isoplanes in the graph sheet. Now the next step is finding the initial point. So in the question, they have given us E of 0 is equal to 1.5 and E dash of 0 equal to 0. So what is E? E of 0 means, that is initial conditions are given as E of 0 and E dash of 0. That are our initial conditions. So what is our E? E is equal to x1. What is our E dot? E dot is equal to x2. So initial condition is that x1 is 1.5 and x2 is equal to 0. That is our initial condition. So the phase trajectory will start from this point 1.5, 0. Now how can you choose the next point in the phase trajectory? So we can choose the next point by, so this is this point, that is this isoplane, that is the isoplane as x-axis. At x-axis, s will be equal to infinity, the slope s will be equal to infinity at x-axis, and alpha will be equal to tan inverse of infinity equal to 90 degree. In x-axis, the slope will be equal to infinity and alpha equal to 90 degree. So for plotting the next point, the first point or initial point is this. For plotting the next point, here in this point, in this isoplane, take the angle. So at x-axis the angle is plus 90 degree or 90 degree. So plot that angle with respect to this point, mark that angle 90 degree and extend that line to the next isoplane. Extend the angle line or angle marking to the next isoplane. Now take the next slope. So here this slope is at s is equal to 2. You can see this slope or this isoplane, this isoplane is at s is equal to 2. So at s is equal to 2, the angle is plus 63 degree. So here you have to take from this point again, you have to take plus 63 degree. Plus 63 degree will be in this direction. Okay, I am the direction of 63 degrees like this. So take plus 63 degree, again mark that angle here and extend that point to the next slope. So here you got 2 points. One is the extension of plus 90 degree and other is the extension of plus 63 degree. Now find the midpoint of this section, this line segment. Find the midpoint of this line segment. That midpoint will be the path of the phase trajectory. So initial point is A and the path of the phase trajectory at the next isoplane is B. That is the midpoint of plus 63 and plus 90 degree. Similarly, for finding the next point, that is here this point C, from this point B, draw a horizontal line at this point B and mark the angle at this slope. The angle at this slope is 63 degree. So plus 63, mark plus 63 here. Extend that to the next slope, S is equal to 1. This slope is, you can see this slope is S is equal to 1. And at S is equal to 1, the angle is 45 degree. So from this horizontal point, mark that angle 45 degree and extend that point to the next isoplane. So here you get 2 points like this. Here this is one point and here this is another point. Again find the midpoint of this and the next isoplane will be like this. Similarly you have to continue. So while drawing the method of isoplane, you have to draw from the initial point, you have to draw the isoplanes in clockwise direction only. That you have to keep in mind, in clockwise direction. And when you get a path like this, you can see the distance from the origin. Here it is 1.5. When you reach here, it drastically or it decreases. You can see the change. The distance from the origin actually decreases. That means this type of isoclanes, the type of isoclane will be spiraling towards the origin. When you go here, etc., it will be spiraling towards the origin. So you have to only draw up to this, and if you see this one is decreasing in the distance, you can just draw a spiraling trajectory towards the origin, and from the shape of this spiraling trajectory you can say that this is a stable focus. The type of the singular point is stable focus. That is, from the graph you can say that the type of the phase trajectory is stable focus. Before seeing this lecture, please go through the textbook Advanced Control Theory or the materials I have given, the note material I have given. I think in the Advanced Control Theory by Nagurkani explained very well. The method of isoplane, it explained very well.